Okay, let's do section 2.3, the chain rule. Awesome. I'm a little late with putting this video out, so I'll just move the deadline a little bit. Alright, right away they want to start us off looking at the exponential function. That's cool. The exponential function is easy to do the chain rule with, but let's just let's look at what the chain rule is in general, and then you can see how it coincides with what we know about how to differentiate the exponential function. So in general, the chain rule is talking about the composition of two functions. You have this other function, right, being evaluated, or you have your function f being evaluated at this other function. And I want to say here that the chain rule is the product, it is the product of two derivatives. We wish the product rule was this easy. It is not. But the chain rule is just the product of two derivatives. I need to know f prime, and I need to know g prime. Only thing is, these guys don't get evaluated at x. Not both of them. G prime gets evaluated at x, but f prime gets evaluated at g of x. And as you can see, it's just this derivative times this derivative. Now, you probably already knew this, right? Because of the problems on exponential functions and logarithmic functions derivatives. When we had, what was our rule for if I wanted to differentiate some exponential function, right, e to the g of x, then what I needed to do was I needed to multiply, I needed to find the derivative of that exponent, and then it will just get multiplied by the thing that I started with. Now these are the same. This property is the same as what we just stated if you just observe that f of x is e to the x and g of x is just whatever it is. So then f of g of x would be equal to e to the power of g of x. So you've been doing chain rule already and didn't even realize it. Now our problems here, or our problem, the first problem I'm given says that we have a function and it is e to the minus 2x plus e to the 3x. All right. So f prime of x, the derivative of this guy, has got to be the derivative of minus 2x times e to the minus 2x plus the derivative of 3x times e to the 3x. you get minus 2e to the minus 2x plus 3e to the 3x. So that's minus 2e to the power of minus 2x plus 3e to the power of 3x. All right, here's our function, minus 9e to this exponent. Okay, super. Then we will need to find the derivative of that exponent. And the rest of it we just get to kind of rewrite. So our function y of x is minus 9e to the power of x to the minus 9. The derivative of y would be, well, my minus 9 just comes out front. And then right there I want to write the derivative of x to the minus 9. And then the rest of this is just the e to the x to the minus 9. And by the way, this really says this. It's e to this exponent. And here I want the derivative of that exponent. So the derivative of that exponent would be minus 9x to the minus 10. All right, so we can see that it's 81x to the minus 10 e to the power of x to the minus 9. This one we ought to be able to see straight away. You know, the minus, so the x to the minus 7 differentiates like the minus 7 comes down, and then it's times x to the minus 8. And then the exponential function, that's almost second nature by now. We could just type out our answer here, but I'll go ahead and work it for you since I cheated on the last one and it didn't work. G of x is x to the 4th plus e to the minus x. G prime has got to be 4x cubed minus e to the minus x. It's like this. It's, you know, here's my plus sign. It's that same plus sign, and then the derivative of minus x. That's minus 1, and then e to the minus x. So that's how we get 4x cubed minus e to the minus x. Okay, 33% mastery. Here's another one that we already know how to do. But so here's maybe a good opportunity for us to kind of disassemble the chain rule a little bit. Like, we know how to do this. It's the answer is a fraction whose numerator is the derivative of that polynomial inside the logarithm, and whose denominator is just that very same polynomial. But let's just kind of examine our, I'm going to rename that function as h. And I want to show you how this function h is really some f of g of x. Where f of x let me not use x. X is busy. Let's use f of z. F of z is just the natural log of z, and g of x is that polynomial, 3x cubed plus 4x squared plus x plus 4. If you don't like z, put a star. Means the same, might as well be the same thing. I mean, they're both symbols. Star is not one of our alphabetic letters, but that's okay, doesn't matter. The chain rule says that h prime has got to be a product of two derivatives. You'll have g prime of x, right? That's one of the derivatives, and the other one is the derivative of f, but you don't evaluate it at x, you evaluate it at g of x. So f prime of star would have to be, from what we know, it's 1 over star. And g prime, from what we know, would have to be 9x squared plus 8x plus 1. So then, evidently, f prime evaluated at g of x would just be 1 over g of x, and then times g prime of x, right? But g prime is exactly the 9x squared plus 8x plus 1, and g of x was the polynomial we started with, 3x cubed plus 4x squared plus x plus 4, and it's this polynomial times 1, so it's really just the fraction with g as its numerator and g prime as its denominator. So we ought to be able to do this one then, just basically without even doing any much work. It's this one. I didn't even take a derivative. I know it's that one. It's the only one that has the correct. So it's the only one. So there's two of them on here that have the correct denominator. But this one, the first one, absolutely has the wrong numerator. The answer must be this. And of course you can verify that, yeah, that is the correct numerator. Again, with one of these, is this not the very same problem we just did? And it's pretty close, but not exactly the same. Here's our answer. What is the first derivative of this thing? Okay. It's right here. These natural log ones are actually not that interesting. It's this exact setup where the natural log function is the f, and the argument inside the natural log is the g. So it ends up looking like 1 over g times the derivative of g. Let's see what else they got. All right, on to some new chain rule problems. If you had to do this derivative right here, you could multiply that out. You might make a mistake, but you could do it. We're not going to, because it's a headache, and the chain rule makes it so that you don't need to. In fact, I will even go further here than the way the problem is set up and say that I want to alter it a little bit so that it becomes even easier. Because there's an opportunity here for me to avoid the quotient rule. If you can avoid the quotient rule, you should. Now that says the exact same thing. And according to our exponent properties, that is the same thing as this. This is f of x. This is the guy I'd much rather find the derivative of. Much rather. So, let us do it. Instead of calling this guy f, I want to just use h. The problem labeled it f, I'm going to call it h. Then, according to the chain rule, h prime would have to be the product of two derivatives. It's the product of f prime and g prime. But it's not f prime of x and g prime of x, it's f prime of g of x and g prime of x. Right? The stuff that goes in here is not the same. And we can identify what f and g are. This will become an f of g of x, like is needed to do the chain rule, whenever f of star is star to the minus 3 and g of x is 2x plus 3. And I know f prime, right? F prime has got to look like, f prime of star has got to look like minus 3 star to the minus 4. And g prime has got to look like 2. It's always 2. So our derivative would be minus 3, and in there is my star, right? But I'm not going to put star because I'm going to put g of x. And then it's to the minus 4, and then it's times g prime, which is 2. And instead of putting the star, I put g of x. G of x is 2x plus 3. Simplify this, you get minus 6 times the quantity, 2x plus 3 to the minus 4. So we have minus 6 times the quantity, 2x plus 3, it's not a plus, to the power of minus 4. Here's another one like that. I am not at all interested in doing the product rule on this thing, so help me. It's so far it's the #1 complaint of the semester from you all. And if there's a chance to avoid it, then let's do that. We can avoid that right here. they've given us h of x as 1 over this thing. It's this thing cubed. You make more space for that thing. It's a minus 3x squared plus 3x minus 2, and then you cube it. There's h of x. This is identical to minus 3x squared plus 3x minus 2 to the power of minus 3. So if f of star is just star to the minus 3, and g of x is minus 3x squared plus 3x minus 2, then what we have is that h of x is f of g of x. H prime has got to equal the product of two derivatives it's the product of f prime and the product of g prime but it's g prime of x and f prime of g of x. So then h prime of x has got to equal, well, f prime was, that's not a star, f prime was a star to the, oh, I guess I need to do f prime. I haven't done it yet. F prime, come on, f prime was minus 3 star to the minus 4, and g prime was minus 6x plus 3. Now we can see that h prime, since it needs to be f prime times g prime, where here we put in g of x and over here is just x, then now I can just look at my derivatives, right? It's those two things multiplied together, where the only thing I need to modify is instead of putting star, I'm going to put g of x. So it's a minus 3 times g to the minus 4, and then times minus 6x plus 3. And then what was g? G was minus 3x squared plus 3x minus 2. Now that's our answer, and we'll just leave it like that. That's okay with the instructions. It says you can just leave your answer in factored form. Yeah, do not try and spend any time to, unless somebody has explicitly said, I need this simplified heavily, don't bother doing that. You're likely to make a mistake if you start doing a bunch of algebra to it to get it to look like something you want, and there may not be a good reason for you to make it look that way. All right. .83% mastery. See, now here's one that you're probably not, I mean, you could FOIL that out. Not FOIL, but multiply that out. But you won't. It's to the 5th power. That's way too much trouble. This to the 5th power, you know, the point here is that, yeah, we're learning how to do it when it's just to the 5th power, but this will also work if it's to the 50th power or the 500th. That's where the real, I guess, power comes in, because you are certainly not going to do it if it's to the 50th or 500th power. All right, I've got my equation written. There it is. You know the drill by now. Do not mess around with the stupid quotient rule. Just come in here and say 2x squared plus 2x plus 1 to the minus 5th. Let's see if we can just write h prime this time. We can see that the general shape, like if I took my glasses off and looked at this h of x, it looks like this to the minus 5. That's what I see when I squint my eyes and look at it from real far away. So the minus 5 has to come down, and then it's just all that stuff to the minus 6. This is what the derivative of something to the minus 5 looks like. This is what the derivative of this looks like. And that's all we've got written. So there's our first derivative, and then it's times this other derivative, which is what? 4x plus 2. And what goes right in here? It goes 2x squared plus 2x plus 1. We're done. That is our solution. Nothing to it. All right, so here I'll have, come on, 2x squared plus 2x plus 1 to the power of minus 6, and then times 4x plus 2. %92 mastery. I get the feeling I know, or I get the feeling that this next one is the last one. I hope that this stuff is helping y'all, and it makes your homework not be as long. Evidently, they're just going to ask you the same types of problems, try and get you conned into doing a quotient rule, but you're not going to fall for it. Even if you did, it shouldn't be too big of a deal, because the numerator each time has just been 1. Even if that numerator wasn't 1, we could at least convert it to a product rule instead of a quotient rule. This is what they gave us. I mean, if I had to do this, if I just had to, if they said do it by quotient rule because I want to see it, then, you know, I'd need the derivative of the top, which is 0, times the bottom. Okay, 0 times the bottom. Great, there it is. And then minus the derivative of the bottom times the top. Well, the times the top part will be times 1, so won't have to write that. The derivative of the bottom is something else in it, because we'll have to say 5 times 3x squared plus x plus 2 to the 4th, right? And then it would be times the thing on the inside, 6x plus 1. And then it would be over the bottom squared, 3x squared plus x plus 2. And then it's to the 5th, and then squared, so that would be to the 10th power. But when you simplify this, you get a minus 5, 6x plus 1, over 3x squared plus x plus 2 to the 6th power. But see that that is exactly the same as what we would have gotten if we would have just said instead that h of x is really 3x squared plus x plus 2 to the minus 5. So that h prime of x would be, I just have this one thing to differentiate now. I'm not having it like nested inside of a quotient rule. It's minus 5 and then times that stuff to the minus 6 and then times the derivative of that inner part, 6x plus 1. And the stuff that goes right here is that polynomial that we just took the derivative of. And these are the same. Okay. So let's type it in, make sure everything's hunky-dory. Alright, 3x squared plus x plus 2 to the power of minus 6, and then times quantity 6x plus 1. Awesome. And that's all. Talk to you later.